Hi everyone, a little quick introduction to area. We're doing measurement and we're going to zoom along pretty quickly. We've done this a couple of times already, whereby it's your job to watch this and do a quick bit of revision and we can move along pretty quickly in class. This is just year 7 and 8 stuff, so I don't want to just muck around for a couple of doubles on it or a double class on it. I want to get into the harder stuff in class. So we're going to have a look at some area here, and with a bit of revision from yourself, you should be ready to rock and roll in class a little bit faster. If I haven't already, I'll be getting you to copy this into your rules book. It's just some of the basic formulas we use for calculating area. As you can see, we've got the shape, the formula, and a little explanation that L times W means length times width. That's pretty simple, but I thought it was worth explaining anyway. Look, that's basically it. If you haven't copied this in your book already, then you will be soon. Very quickly, this is really basic stuff. Area is not a distance that you measure. It's not a straight line distance. Area means the space or area in, well, I guess, and I can't think of another word but area, but think about a room. How much space is in that room. I tend to try and think of it as floor space often, and we have to measure it in square whatevers. Is it square centimeters, square meters, square kilometers, whatever. A square centimeter, as I've got 80 of them here, is a square shape. That's a centimeter by a centimeter by a centimeter by a centimeter. And this particular shape is 10 long and 8 wide. Actually, I think it's 8, 1, 2, 3, 4, 5, 6, 7, yep, 8 wide, so that would be 80 square centimeters. Now, I think you probably knew that anyway, but I thought it was worth mentioning. Let's have a look at some really simple examples. Now, I often say to people, nobody sucks at measurement. It's really quite straightforward. You have a formula, you then have the numbers to fill in, and then your brain or your calculator, depending on how hard it is, will do the rest of the work. So I'm not going to accept anyone finding this sort of stuff hard. It's really, really simple. Let's have a look at the first thing. This is a rectangle. It's 7 centimeters long by 4 centimeters wide. Your first step, you always write a formula. Area equals length times width, or L times W. You always write a formula, and pretty much all of our problems that we do will require 3 lines of work. Next step, replace the letters with their matching numbers. The length of this shape is 7, so instead of L, we write 7. The width of it is 4. Instead of W, we write 4. That's your second line. Now the calculator or your brain takes over. Third line is just the answer. 7 fours are 28. That particular shape is 28 squared centimeters, or centimeters squared. Notice 3 neat, clear lines. Equals, under, equals, perfectly, neatly. That is what I will be demanding from you. Let's have a look at a triangle here now. There's your formula, a half BH. You should already know that B stands for the base, from there to there, 10 meters, and H stands for the vertical height. Not the length of one of the sides of the triangle, but the actual perpendicular or vertical, that's straight up and down height. That's the measurements that you need. So once again, you've got something pretty simple here. There's your formula. The measurements you want are marked clearly on the shape, so your next step is just to swap the letters with the numbers. So a half times 10 times 15 gives you 75 meters squared. I jumped a bit quickly there. The base is 10, so B gets swapped with 10. The vertical height is 15. The calculator does the rest. A half times 10 times 15 is 75. The area of this shape, 75 meters squared. We'll move a bit faster now. I'm going to do the whole lot all in one. Here's a circle. Very important part of the circle area is knowing the radius. The radius is 6.5 meters squared. 6.5 meters. You might be tricked on occasion and given the whole length across, which is the diameter. That's something for another lesson though. This is just a little introduction, so I won't confuse you. There's your radius. So here's your formula. It all comes up at once this time because I'm going a bit faster. Area equals pi r squared, which is pi times the radius squared. As always, second line, swap the letters for the numbers. Pi is not a letter, it's a number, so we leave pi there. You've got a pi button on your calculator, so we can just leave pi there, times the radius, which is 6.5 squared. That's exactly what you type into your calculator, and your answer is 132.7 meters squared. Again, please note, beautiful, neat, clear, 3 lines, equals, under, equals, everything perfectly obvious. Let's have another look. A trapezium. A trapezium is no harder than anything else, although its formula is in fact a little bit harder to remember. The formula is a half times the bracket of a plus b times h. And before you freak out with, oh, that's really hard, it's not. A and b are the two parallel sides. I should have little arrows on them, I apologise, to show that they're parallel, but I forgot to put them on. This side that's 8 and this side that's 14 are your two parallel sides of your trapezium. Your A and your B are simply those. It doesn't matter which one's A and which one's B. As you look at the next line, it equals a half times, now in the bracket is 14 plus 8. Those two sides added together times 10, which is the vertical height. So you've swapped your letters for your numbers again, and there's the next step done. Please be aware and careful. This is 14 plus 8, A plus B, not times. That's a really common mistake that we often find Year 9s making. The calculator does the rest, 110 centimetres squared. So again, it's just simply formula, substitute the letters for the numbers that are already given to you, and then get the calculator to do the rest. Easy peasy, lemon squeezy. Let's have a look at a parallelogram. I'm not going to do every single shape here. I've skipped over a couple of shapes. The formula was on the first slide. The formulas will be in your book. We can talk about those another time. I just want you to get the basics down here. This is a parallelogram. Pretty easy formula. Base times height. Not length times width. It's base here, which is like the length, I guess. But then again, the vertical height. Not the side of it there. Not that side of the shape, but the vertical height. It's not a great deal different. One thing I'm showing you here differently is just another way that we show vertical height. I could have marked it just in there with arrows, but often on shapes, they mark it outside with a right angle like that. What it should be is it should be dotted, but I couldn't work out how to do a dotted line. I don't think you can, so I just had to put permanent lines there, and one of them, that should be red as well, I just mucked up there. Yeah, so often this is shown as like dotted lines and a right angle, which basically shows you, well, if that's a right angle, then this line has to be perfectly straight, so therefore the 9 is showing you the vertical height. It's just another way of showing you vertical height. You'll see it in the textbook and other places. It'll be marked by dotted lines. No, the dotted lines actually mean it's not part of the actual shape, it's just showing you a measurement. That's what dotted lines usually are. So there's your formula, substitute in the numbers. Duh, now it's getting a bit basic, isn't it? A bit of the same old. Calculator does the rest. There's your answer. That's the area of that parallelogram, 135 meters squared. Alrighty, just a couple of things to go over. It really is just like common sense, guys. I keep harping on it that no one sucks at measurement because I think it's really that basic. There is a slightly different one, a little bit here, that has a little bit more thought to it. Just a little bit here. Right, so it's a bit more thought right for this. I don't want you to find the area of this. That's something we're going to get to. That's what we're going to start with in class after we've done the revision of this PowerPoint. But there is often a hidden measurement, and that's what you've got to get good at finding. Here's a square at the bottom. So that would be 13 by 13 by 13 by 13. So that would be easy to do. The triangle here, though, as you know from your formula, we need the base, which is, well, if that's 13, then that's 13, so that's easy enough. But we don't know the vertical height of it. That's okay. Out here, the whole length of the shape is marked as 30 centimetres. So if it's 13 from there to there, it has to be 17 from there to there to make up the 30 centimetres. So just, it's not marked on the diagram, but just by a little bit of common sense maybe, you can pretty quickly work out that the vertical height of the triangle is 17, because 17 and 13 is 30. All right, guys, that's about it. I hope you've got a lot out of this and that you really understand it quickly, because I really want to move on to harder stuff in class. I didn't want to spend a lot of time in class just going over and over this. So good luck, and I'll see you at the learning place. Bye.